Let's now investigate the effect of adding resistance in series on current strength. First, though, we need to understand some terms that we're going to use in the investigations we're going to do. Current strength is the rate at which electric current flows. The symbol is I and the unit is amperes. We measure current strength with an ammeter, and we must always connect an ammeter in series in a circuit. How can you see that it's in series? You have to break a circuit to let the ammeter in, and after connecting it you can see there's only one path through the ammeter and the current must flow through it. A resistor is an electronic component as shown in the picture, and it has resistance. Resistance is a property which some components like resistors and bulbs have, and resistance means how difficult that component makes it for electric current to flow through it. The symbol of resistance is R and its unit is ohms. What does inverse proportion mean? Inverse proportion means that as the independent variable is increased, the dependent variable decreases by the same factor. What do I mean by that? Let's say the independent variable is increased from 1 till 5. The dependent variable might be like this. 1 corresponding to when the independent variable is 5, 1,25 for the independent variable of 4, 1,67 corresponding to 3, 2,5 corresponding to 2, and 5 corresponding to 1. How can we see that this is an example of inverse proportion? Well, first of all, we can see that the higher independent variable, 5, corresponds to a lower dependent variable, 1, and the other way round. The low independent variable value, 1, corresponds to the higher, the bigger dependent variable, 5. So when one is big, the other is small. When one is small, the other is big. That's one characteristic of inverse proportion. But it's not enough. It also has to be by the same factor. How can we see that this is by the same factor? Well, let's look, for example, at the comparison of 1 and 2 for the independent variable. How does 2 compare to 1? Of course, 2 is double 1. Now we look at the corresponding dependent variables, and they are 5 and 2,5. How does 5 compare to 2,5? 5 is double 2,5, or we can say 2,5 is half 5. So as our independent variable changed from 1 to 2, it doubled, and that corresponded to a halving of the dependent variable from 5 to 2,5. 1 times 2 equals 2. 5 divided by 2 equals 2,5. What about if we look at 1 and 3 from the independent variable values? The independent variable has tripled, increased threefold. 1 times 3 equals 3. And the dependent variable has correspondingly decreased threefold. 5 divided by 3 equals 1,67. Let's compare 2 and 4 and 2,5 and 1,25. To go from 2 to 4, you double the value. 2 times 2 equals 4. To go from 2,5 to 1,25, you must halve the value. 2,5 divided by 2 equals 1,25. So we can see that as one variable is increased, the other one decreases by the same factor. Another way we can detect inverse proportion is that in inverse proportion, the independent variable multiplied by the dependent variable gives a constant. What that constant is differs between different sets of values. For this particular set of values, the constant happens to be 5. Let's check that. 5 times 1 equals 5. 4 times 1,25 equals 5. 3 times 1,67, it's actually 1,6 recurring, equals 5. 2 times 2,5 also equals 5. And obviously 1 times 5 equals 5. Another way you can detect inverse proportion is that it gives this shape of a graph. Here we have the x values, 5, 4, 3, 2, 1, the independent variable values plotted on the x-axis against the dependent variable values, and it gives this kind of a graph.